Hello, I'm Rachael McDonnell. I'm the Deputy Director General of the International Water Management Institute, and it's a great honour for me to give this keynote address to the Water for Food Global Forum. I am delighted that I'm a Global Fellow for DWFI, and I have always enjoyed working with Nebraska on a number of different projects. So I'm delighted to be joining you today to share some of that insight. I'm just going to share my screen. So I'm delighted to be here to talk to you about the challenge of extremes. We're unfortunately seeing more and more of those images of people suffering from droughts or floods or forest fires that we know are coming from this changing climate that we're all having to adjust to, the new normal. We can see that business as usual is not working. We're having this summer, there's been a series of reports come out. The IPCC working group 1 really was a wake-up call from this robust scientific set of evidence. They are now incontrovertible truths emerging. We've also seen major headlines coming from the UN Food Systems Summit in September, where there's a great call for transformation, for change of our food systems, and that includes making agricultural systems and food systems part of climate mitigation, as well as what is needed for climate adaptation. The picture there on the bottom right is taken from Milan. 2 weeks ago, it was the pre-COP in Milan. And what we heard from that meeting was the outrage of the young next generation, the youth, who are saying, this is our future that you're gambling with in those negotiations. And of course, we will be at the COP26 in Glasgow, where we really hope some agreements can take forward the negotiations, what was agreed in Paris 5-6 years ago now. So let's just look at what that 6th assessment report said. And it was very incontrovertible. With every additional amount of global warming, the changes get larger. So you can see the changes there under 1.5 degrees, the Paris Agreement limits that we were going to keep to, but we're already at 1.1. We're very much heading towards 2 degrees and 4 degrees. And unfortunately, it isn't just an incremental, it's an extreme change that happens with them. When it comes to water, we can see that for every 1 degree increase in 1 degree centigrade, the extreme rainfalls intensify by 7%. So this is a big increase for many areas. Why is that? Well, it comes from a change in the heating systems that then bring those imbalances then in what would be the normal hydrological cycle we see. The IPCC said it is indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rain, and droughts, more frequent and severe. So we can see these climate extremes are highlighting, are being shown to be more likely to occur, and when they do occur, they will be more intense. So why is that? Well, what we see is without those warmer temperatures that was on the earlier graph, the atmosphere can hold more water, and this brings more and faster evaporation. We get more energy in that water cycle, and that leads to heavier precipitation. So we can see that movement that we've all become accustomed to from the atmosphere to the land, to the ocean, and into the freezing regions. This becomes more energized. And then what that then brings is both heavier rainfall, but also more intensive drying seasons of droughts. So we can begin to see why those climate cycles or those climate extremes are becoming much more part of our everyday life. What was interesting about the Working Group 1 IPCC report, it was able to draw on up to the 40 years of data. So this isn't speculating what's happening in the future. They're able to see what have been the changes in our lifetimes. And we can see from that top chart, and you can see that the way they've represented the world in this schematic way, there has been an increase in droughts in many areas. Southern Africa, parts of Latin America, parts of North America, but look at that great swathe through Europe and going into South Asia, Southeast Asia. This is where we're seeing great changes, both in rainfall in the top graph, and then in the bottom graph, the increase in droughts. So these are observed changes. These are not predictions. This is what the scientific evidence is showing us. And then what are we going to look at? What's going to happen in the future? Well, the IPCC gives us, again, looking at both floods and droughts, they see that for 1.5 degrees in temperature, we're going to have 1.5 times more heavy precipitation events, those 10-year events. But when we get to 2 degrees and 4 degrees, then the likelihood of occurrence increases by 1.7 and then 2.7 degrees. And then when we look at agricultural ecological droughts, looking again at the 10-year event, that can often be quite devastating. We can see 1.5 degrees will double the likely increases. But when we get to 2 degrees and 4 degrees, we're going up by 2.4 times and then 4.1 times. So droughts will become more frequent and more intense, according to the predictions, and that's for the 10-year event. So what are we doing now? If we look around the corner from what we can see from the IPCC reporting and the modeling, it really is quite scary. Too much water, too little water at different times to what we're used to. So the growing season is delayed, or it finishes earlier, or it evaporates too quickly. This is what our future is going to look like. So what can we do? Well, the Global Commission on Adaptation met in September 2019 and really galvanized adaptation work. And as part of that, a background paper called Adaptations that looked at what we can do. So what is the framework that we can use for building resilience? Well, there are 4 parts to that, and those really need to come together if we're going to have sustainable, but also robust and flexibility in our adaptation, because we really don't know what's around the corner in many areas. We have to have system diversity and connectivity. We cannot just look at the water system by itself. We have to bring the food system, the energy system, and ecosystems, because we know they are all connected. We know that there has to be changes in governance. The climate change that we're seeing in the future is really going to challenge our laws and our regulations and our allocations. How much water goes to agriculture? How much water goes to for people? How much goes to industry? So we're seeing that some of that is going to be challenged, and we need to look at what does that new governance need to look like, and how can we bring a participatory approach to that so that we have a buy-in and understanding. We need more data, information, and learning, and we also need technology and management and infrastructure to be able to adjust to those new normals. But what is important is understanding the uncertainty in developing any of these systems going forward, because those rapid changing feedbacks and loops that we have in our system. So what are we going to do? So we need to look at both climate adaptation and mitigation. First and foremost, we really do need to mitigate, because we could see from those figures trying to put off the changes that are there are the best way that we can adapt. So how can we mitigate to reduce those climate extremes? Well, of course, reducing greenhouse gas emissions, and for that, in the type of work that we do, we need to think about how can we decarbonize agricultural water systems. We have to reduce the amount of emissions going into the atmosphere. We can also do that with different cropping, with many different ways, different livestock management, that we can reduce the amount of greenhouse gas emissions. And some of the work at EME we've been working on is solar irrigation. We need to increase the amount of greenhouse gas sequestration. So as we're developing our agriculture systems, as our farming systems, where can we also include greenhouse gas sinks? It might be on the edges of farmland. It might be the way we crop, the way we manage our soils, the way we do things like conservation tillages. How can we increase our greenhouse gas sequestration? We have to develop finance systems to support it. Who's going to pay the farmer or the water manager to undertake these various actions? And at the moment, we cannot rely on international development funds or governments to support that. So we need to be able to design solutions that are going to attract some of the new financing that's available, sustainable finance, impact investment. How can we help companies offset their carbon? How can we look at helping them as they strive to be more carbon neutral? What sort of solutions can we, investable solutions can we develop to, to marry these two drivers together? And we also need drivers for change. We know that policies, regulations, changes in markets, changes in diet, these are the big drivers that can bring the introduction of those solutions and bring to scale what is needed. So the best way to manage climate extremes is to mitigate the climate to start with. But we know that that's going to be very difficult. So then if we take that framework we were thinking about just now, how can we mitigate the risk that goes with climate extremes? Well, one area is through risk identification. Where is the drought? When is the flood? When will it happen? What has been the past hazards? Where are we most vulnerable? And can we quantify that risk? So that data, information, and learning is important. Governance and participation, particularly linked to infrastructure technology management, can allow us to bring together drought preparedness, risk reduction, drought and flood management, mitigation, as well as risk transfer by looking at, can we use financial risk instruments like insurance? This is commonplace in the US, but in many of the countries we work in, this is only just beginning. How do we pay the farmer when the farmer has lost their crop for this year, their livestock for this year? How can we help them get back onto their feet again? And so often things like insurance and base systems or these type of mitigation areas are critical in not stopping the impact of the risk, but helping to ameliorate and speed up the response to that. And of course, things like system diversity and connectivity, trying to look at, can we bring in more diverse agricultural systems? Can irrigation be a part of understanding that? How can we link green energy, green and green land management with many different areas in system diversity? As I said, we need to really look across the water, energy, food, environment nexus to help see whether can we bridging risk reduction. We might be able to reduce the impact on the farmer and the water system upstream or downstream or around in that landscape that can then offset the impacts of the extremes. What the IPCC report said very clearly is that many of these extremes will either be ameliorated or exacerbated by local conditions. So building in system diversity and connectivity is important. So one of the examples I wanted to give, it's a project that we have been working with the University of Nebraska, the National Drought Mitigation Center with since 2015. And this is it's dealing with drought impacts in the Middle East, North Africa, the MENA Drought Project. And as you already know, this is a water scarce area, so drought impacts are really felt. Building on, well, it was the initial work of Nebraska, Don Wilhite, and then this was transferred into the International Drought Risk Management Framework based on the 3 pillars of drought risk management: monitoring, early warning system, vulnerability and impact assessment, and preparedness, mitigation, response. And we can see how these map onto that framework that we spoke about a little bit earlier about managing water and climate adaptation, resilience building. So if I can give you some examples of what we have done under those 3 pillars in Jordan, Morocco, and Lebanon. So the drought monitoring, building on what you have at Nebraska from the US National Drought Monitor, we've been taking a more simplified version to represent the data uncertainty and the data access that we have in the region by generating drought maps for this. And again, we've worked with Nebraska, but also some input from NASA, where we're looking at what are the conditions relative to normal at that particular point, because we know drought is always defined locally. Rainfall, temperature, soil moisture, stress at plants, those are the 4 inputs that we get from satellite and model data going into our drought monitoring. And here we can see the case of Jordan this year. So if you look at that very top small map there, that was taken in October 2020, a year ago now. a little bit of drought. And then if you go along the maps there, we're going into November, then December, January. And although we had a little bit of a winter drought, we then had some rainfall and then it was eased. But then we came to the spring drought and it rapidly became very extreme. And we in areas like Western Tafila here, we can see that this is an extreme drought, and we can see the impacts across the whole of the country. And remember, this is drought indicators relative to normal conditions. So we can see that much of the area was either an exceptional drought or severe drought. And this has had big consequences for the farmers, for the water managers in the country. And there have been various drought payouts based on this map, but it really is catalyzing the efforts that Nebraska and IMI have had in the country working with USAID. So when we also look at drought impacts, any sort of extreme impacts, we need to not only look at what is the hazard, is it a drought or a flood, and how severe it is and what it is. We also need to find out who is impacted and which parts of an environment are impacted, which businesses and communities. And so we've undertaken an extensive study of the impacts of past droughts, and we can see them under things like hydrological. It changes the water systems, it changes the impacts, the ecological systems, and the social economic systems. These droughts in the past have had quite linked set of impacts that really have hurt the farmers, the water managers, the population in Jordan. And so by looking at where it was impacted before, we can then take this into our next stage, which is about drought preparedness, mitigation, response. So we have our drought maps. We know where the areas are particularly impacted. And what we have been working on with our Jordanian counterparts, we have been co-developing a national drought action plan for Jordan. In other words, a systematic, proactive response across multiple ministries to say, yes, we know those were the impacts in the past, whether it was on health or on incomes, farmers' incomes, or loss of livestock, or whatever it might be. What do we need to do going forward? So we have been working in a series of workshops, developing drought action plans, building on the rich experience of Nebraska on this, and linking those drought action plans, the drought maps, to triggers that can then bring about the drought action plans, and where there is an ongoing institutional support. So we can see that this has been a critical area of managing drought, managing those climate extremes. Another area that we can do is to help with drought adaptation. We can't stop the drought, but what we can do is we can bring a series of technology solutions. Remember, I was talking about technology and data had a role to play in building resilience. And what we've been doing is we've been working on various climate smart agriculture response. How can we manage water, manage agriculture, different crops, different water management systems? And how can we also support that through climate information systems, highlighting predicted over the next few days to up to 3 months, what will be the likely climate information, and then supporting giving this information helps farmers and water managers respond and to take action. So there's a sort of the piloting, scaling of tested solutions across various technologies and cropping systems. There's providing the knowledge and providing knowledge hubs to those farmers. And there's also, of course, capacity strengthening. This is how we can really make that difference through joining these 3 areas together in our management of droughts and floods. Another area that we've spoken about a little bit is something that IMI has a rich experience in, and this is developing insurance systems. So I spoke about this a little bit earlier about risk transfer. And so what we've been doing is we've been working in parts of South Asia, in Pakistan, in Bangladesh, and in India, looking at how we can work with private sector insurance schemes by providing the data, linking the data to be able to predict where there's floods, and then speeding up the payouts. This has been a really important recent developments. We're looking at helping over 7,000 households, scaling this up. And one of the parts of the design of this has been about inclusiveness. How can we ensure not only those that can hear about it or read about it can access this, but how can we ensure that as we design this index-based flood insurance, we can also ensure women, youth, marginalized groups can also benefit from this, and that has been an important part of our engagement. What we've also found very useful is what we called bundled index insurance with climate information and seed systems. So sometimes having the insurance and receiving the payout isn't enough. What we've been able to do is to help those get back onto feet by listening. What is it people want? They want flood drought resilient seeds. They want index insurance cover, yes, to cover those risks. They want help with new practices in agronomy and fertilizers and water management to help them manage the drought and flood, and also that advisory and climate-based systems. So by bringing these bundle insurance, so looking beyond your normal insurance where you would receive some sort of cash payout, this is helping by working with seed companies, with insurance companies, with working with climate service providers. We have been able to bring this bundled insurance to try and help those adapt to climate extremes, to break that low-tech trap that too many fall into as their social, their natural resource capital, but particularly their cash and their access, their seeds and their livestock are decimated by floods and droughts. So to give some sort of summing up of this, what we know for sure is that we don't know for sure, that uncertainty dominates our future. And the way we need to plan, we need to think in ways we can't rely on the history of an area in terms of what the floods and droughts and the rainfall systems used to be. We now need to look at the new normal, which is about uncertainty. So how do we build adaptation and mitigation to climate extremes based on this uncertainty? What we do know is that we have to think about what are the impacts of those managing the extremes. And what we see is, unfortunately, because they are more intense, they're happening more frequent, they are undoing decades of development and increasing inequality. So they need our rapid attention. What we also know is that technology and data only go so far. They need to link to systems thinking and governance to be able to bring the solutions to help overcome that impact of on some of the most marginalized people, the most vulnerable people to them. So it really is a tall order, and we need Nebraska, our colleagues at Nebraska, but also those involved with the Water for Food Global Forums to come together to be able to develop solutions outside our normal thinking to deal with that uncertainty and think about robustness and flexibility that is as part of those joined up areas. Thank you very much for including me in the Global Water Forum. I've always thoroughly enjoyed attending these events. I always learn so much, and I'm sorry we can't be there in person this year. But please know that EME, as a partner of the Water for Food Institute and many beyond that, are very much wanting to support the work of the Institute and all those involved with these forum. Thank you very much.